what actually happens when you hit run on a Java program. How does the code you write get turned into something your computer can understand and run? Let's uncover that today. In our last video, we wrote our first Java program, the Crux press that prints out a birthday message. We started by setting up our environment, downloading the editor to manage our code, and the JDK, your toolbox for writing, compiling, and debugging programs. Then we wrote a Java file called cruxpress.java, hit run, and let's just say an execution engine came into play to run the program. And we got our output, Happy Birthday April. To really understand how that happened, we need to look inside this execution engine. Remember in the last video, we talked about Java being a platform as well? Well, this execution engine is the Java platform that makes it all possible. If you're wondering what a platform is, let me explain. A platform is the hardware or software environment where a program runs. Common platform includes Windows, Linux, and macOS. Most platforms combine an operating system and hardware. But Java is different. The Java platform is a software-only platform that runs on top of other platforms. The Java platform has two key components: the Java application interface and the Java virtual machine. The Java application interface, or the Java API, is a collection of pre-built software components that are grouped into libraries called packages. These packages make it easier to build programs by providing ready-made tools. For example, java.util is used for data structures like lists and maps, java.io for input and output operations, and java.net for networking tasks. The Java Virtual Machine, or the JVM, is the core of Java platform. The JVM is responsible for executing the Java programs, and it's designed to work on various hardware platforms. Now, if we go back to our program's flow, it's actually the JVM executing the program. But you might be wondering, how do we actually get the JVM? And the answer is the JDK, which you use for development, also contains the JRE. The JRE provides the runtime environment, including the JVM, which is the core component responsible for executing your program seamlessly. I hope you have a clearer picture of the components involved and what they do. Let's break down this further to understand how they work together to execute the program. When you write Java code, like cruxpress.java, you're writing something called source code. This is human-readable code, easy for us to understand, but not for computers. That's where compiler comes in. The Java compiler, which is part of the JDK, takes your .java file and converts into something that is understandable by JVM, a machine code called bytecode, which gets stored in .class file. Bytecode is like a set of instructions that any computer with Java can understand and execute. And that's pretty cool, right? To make this concept easier to understand, let's use an analogy. Imagine you have written a book in your native language. Now, you want it to be understood by readers all around the world. To do that, you would look out for a translator. Think of the compiler as the translator. The compiler takes your book and translates into a universal language, let's say bytecode, that every reader, in our case computer, can understand. So now that we know the compiler turns the Java code into bytecode, let's take a closer look at what happens next with the JVM. When you run your Java program, the JVM takes the bytecode from the .class file and executes it. This is what makes Java platform independent. A class file compiled on one platform can be executed on a JVM of another platform like Windows, Linux, or macOS. And that's why we say, write once, run anywhere. Let's take a look at a quick summary of how it all works. You write the source code in .java file, the compiler converts into .class bytecode, the JVM takes the bytecode and runs it on any system with Java installed. Okay, so why does Java go through all this trouble with bytecode and the JVM? It's because this system gives us some major benefits. Platform independence, your code runs anywhere. Security, the JVM checks your bytecode to make sure it's safe and it won't harm your computer. Performance, the JVM optimizes your program as it runs using something called just-in-time or JIT compilation. Think of it as having a personal coach, making sure your program runs faster and smoother in real time.
Let's see this in action. We'll take our cruxpress.java file and compile it manually so you can see what's happening step by step. I'm using an external terminal, but you can use the inbuilt terminal of IntelliJ. First, we use the javac command to compile the code. However, to run the javac command, you need to set up your environment variables so that your system knows where to find the JDK tools like javac, basically the Java compiler. And once you have set up, you'll be able to run these commands from anywhere in your terminal or command line. Don't worry, I have included the detailed steps in the video description below. Okay, I will run the command. This creates a cruxpress.class file. Now let's open this .class file to see what's inside. If you try opening it directly using a text editor or a terminal command like less, you will see some text mixed with strange symbols. That's not very helpful, right? Instead, we'll use a tool called JavaP, which is part of the JDK. It allows to deassemble the .class file and see the bytecode in a readable format. This bytecode might look a bit intimidating, but each line represents instructions that JVM executes. For example, getStatic grabs the system.out object, LDC loads the string happy birthday April to the memory, invoke virtual calls the println method to print the message. Next, we use the Java command to run the program. And there's our output.
And there you have it. That's what's happening under the hood every time you run a Java program. The Java platform with its compiler and JVM is what makes Java so powerful and versatile. Does the idea of bytecode and the JVM make sense? Let me know in the comments or join the discussion in our community. If you enjoyed this, don't forget to like, subscribe, and share with your fellow coders. See you in the next one.